crazy. So I'm going to pop out of this slideshow and come into this slideshow. So we're going to get started. We ended on that picture last time. So as a little introduction to electricity, we're going to learn how on a very basic level, how electricity works. An electron, you may have learned in science class, is a particle that carries an electric charge. Atoms are made of electrons and protons and neutrons, and we're not going to get into all that. But in reality, electrons are what make electricity happen. Electricity is electrons moving through some sort of material, usually in our case, a wire. This picture has a spool of wire, and then it also shows you some materials stop electrons from flowing through them, and they're called insulators instead of conductors. And these, that's like plastic. So if you've ever held a piece of a wire, like when you just plug something in, there's a plastic coating on the outside, and on the inside, there's a wire that carries one or more wires that carry the electricity along. A circuit is a system of electrical components connected by wires. So this little picture shows you a battery and these wires with clips connecting to a light bulb. That's a simple circuit. Here's another circuit, very similar. This one has a switch in it. So this circuit, well, most circuits, maybe all circuits, let's go ahead and say all circuits are going to have at least one source for electricity and at least one load. A load is something, a source is something that provides electricity, and then a load is something that uses electricity. So in the circuit above, check it out, there's a battery, that's the source, and there's a light bulb, that's a load, and then that switch is not a source and it's not a load, it's just another thing. So I'm not telling you that every part of a circuit is either a source or a load, just that a circuit is going to have at least one source, that's where the power has to come from, and a circuit will have at least one load, something that's using the electricity to get something done. Let's click back here. So we've got the source and the load. And right now in the chat, I'd like you to, this circuit shows a battery as a source. So right now in the chat, I'd just like you to throw out ideas of other things that could be sources of electricity besides a battery. So anyone, where are some other sources of electricity besides batteries? Lightning, awesome. Now, a light bulb is a source of light, but it's a load. A light bulb is a load. It's something that's using the electricity, not that's providing it. So David and Eli, good work. Solar panels are another source. And Anais, thanks. You said that too. So the sun can be a source. Magnets and wind power and a windmill. Yeah, great. And send the chats to everybody. Nuclear power is another source. Greta brought up static electricity. Yeah, that's another source of power. We can't really use static electricity in any way I know to like power a light bulb, but it's definitely electricity, and it definitely is a place. It's a source. Good, great ideas, you guys. Can you think of other examples of loads? So a light bulb in this picture is a load. So let's put some load ideas in the chat. If you're not sure what I mean, imagine the computer you're using right now. That's a load, right? It's something a load is something that is using electricity. A fan, awesome, Eli, thank you. Electric car, yeah, good. A toaster, your refrigerator, a phone, a blender. Yeah, I mean, everything, right? Almost our entire world is a load. My electric guitar is a load, the computer. The lights in your house. Okay, so this slide deck has a couple answers, So electric source, examples: battery, nuclear power plant, solar panel, diesel generator. I put on here a car power port, the car charger port, or, you plug in a USB adapter and charge your phone when you're in the car. Load examples, light bulb, motor, computer, all those things we said already. I wanted to point out here that the battery can be both. It can be a source in a circuit, and it also can be a load. It's a source when it's providing electricity to to something else, like a light or charging your phone or something. But it's a load when it's being charged. So that's an interesting puzzle. A battery can be a source or a load. In our circuit that we're looking at today, I just went back to this battery, light bulb, switch. The battery is definitely a source in this circuit. It's never a load here. It's not being charged by anything. What you see is what you get. We have a battery, a light bulb, and a switch. So, all right. So let's see if we can figure out what's up here. When the solar suitcase that looks like that is charging on a sunny day, what is the source and what is the load? Somebody can unmute themselves and go for it, or say it on the chat, or you can all just be shy and wait for me to tell you the answer.
Isn't the source like the energy of the sun?
Yeah. So the source for this on a sunny day, the source is the solar panel, and we're not running the light right now because it's a sunny day. So the load is the battery. Kind of crazy, but we're taking power from the sun. That's the source in this case, and we're putting it into the battery, storing it up for later. Now, this is almost a perfect slide, but the light bulb should be on. I wish I could, I bet I could make the light bulb look lit up. I'm doing it right now. Oh, come on, back here. Boop, boop. We're gonna make a little yellow light. Can I zoom this in? View. Zoom. Big. Okay. I'm pretending the light's on, right? That would look better for this particular question. Back at it. All right. So now when the solar suitcase is providing illumination at night, what's the source and what's the load? Because it's different. I'm telling you, it's different. So feel free to unmute and say if you're feeling brave. Jack just said it. Thank you, Jack. The source is the battery at night, and the load is the light. Yeah, doesn't it look better with the light lit up? So when it's during the day, we're charging, the source is the solar panel. That's where the electricity is coming from, and it's going into the battery. And then when it's at night, the solar panel is not generating any electricity. It's dark. The battery is the source, and the light is the load. Now, if you had the light on during the day, it would also be a load. Like you could be in a room that needs some light. That's entirely possible. Okay, not too many more things. So thanks for hanging with me here. We're going to be using DC electricity, which stands for direct current. This is, there's two types of electricity. You may have heard of them. There's DC and there's AC. And yeah, I think that's why that band named themselves AC/DC, because they were like, hey, we're electrifying, or whatever, or it just sounded cool. But yeah, DC is direct current. That's what's used in electronic devices like your phone and inside of the computer and LED lights, and our solar suitcases are all DC current. And then the other type of electricity is called AC, or alternating current. That's what's in the wall when you plug in things at home. And I know I just said phones and the computers use DC. I know you plug them into the wall, but then part of what happens is, you probably, if you have a Chromebook from school, there's a little power brick. You plug the cord in the wall, and then there's this little brick in line, and then a smaller wire goes from there to your Chromebook. That's converting the AC to DC, because your computer only wants to use direct current. And same with your phone. Your phone, has a little charging brick that you plug in, and then a little cable comes over to the phone, and that cable is providing DC to the phone. All complicated electronics, most complicated electronics use direct current. A DC circuit has a positive side and a negative side. You may have seen that on a battery. Batteries have a plus on one end and a minus on the other end. And same with a solar panel. Some light bulbs care about a positive or negative, and some don't. But every circuit in the solar suitcase has a positive side and a negative side. So if we get to be together in person later this year, then you'll get to see this in practice. For now, you just, I just wanted you to know. If either side of a circuit is cut or disconnected, electricity won't be able to flow. So that's actually what happens when we have a little switch. The switch just cuts the wire, basically, breaks the connection. And then the light bulb goes out and the power stops working. Here we go. Sometimes circuits are broken intentionally by a switch. So check this out. This is actually what's going on. This is almost the entire circuit inside of the solar suitcase. There's this thing called a charge controller, and it has a circuit that connects it to the solar panel. That's the far left thing on the bottom. And then there's the battery, and it has a separate circuit that connects the battery to the charge controller. And then finally, the load or loads has another circuit that connects it to the charge controller. So the charge controller is like the boss. It keeps track of, how much power is in the battery, what's being pulled as a load, and how much power is coming in from the solar panel. And it manages all that stuff because, see, batteries don't want to be run down to nothing. So among other things, a charge controller is going to tell you when you're close to running out of power, so that you don't ruin a battery. And then also batteries don't want to be overcharged. So the charge controller can keep track. Oh, the battery's pretty full. We're gonna not give it any more power because we don't want to cook it. Anyway, these little things represent switches, like on-off switches. And anyway, interesting. So one last little thing: if the positive and negative sides of a circuit are connected without a load in between them, it's called a short circuit. And this can be really bad, especially if you're doing it with a battery. It gets very hot. It can start a fire and cause trouble. So don't connect the plus and minus of a circuit together without something in between, without a load. You're not going to have a chance to do that right now. But that's our presentation. So let's see, I'll stop this. No, I'll leave the slideshow on for just one more second. We've got, boy, that's zoomed in. The assignment for today is to go, I have a PDF, I'm posting it right now. There's a mode in Tinkercad that lets you build circuits. It's kind of crazy. I'll show you. In Tinkercad, if you're still looking at the screen share just for another minute, when you log in over here on the far left, there's under 3D designs, there's something that says circuits. So if you click on that, you can create a new circuit, and it's very familiar to you. It'll be like all the things we've been doing before, except instead of dragging over a rectangle or something, you can drag over a switch. And I'm asking you to go up here and say all components. And then I want you to grab a slide switch and a regular light bulb, this one, and a battery. This is all in the PDF. And then I'm asking you to connect these to make a circuit. And then I guess I could show you, I'll show you on one that I've already done. The circuit mode in Tinkercad has a simulation button at the top. And when you click on that, it actually will turn on the light bulb. It's pretty cool. And then if you flip the switch, the light bulb will turn on and off. So that's part of today's assignment. I want to see the light bulb on. So when you turn in the project, I've got 2 questions I want you to answer in a Google Doc. And then I want you to put a picture of this into the Google Doc. It sounds complicated. It's not. You just click the share button and there's a way to download a little picture of your project, and then you could pop it in your Google Doc. So at this point, I think I'm going to stop talking. I'm going to stop recording.